bounce number and rebound height. So we're going to be dropping, Mr. Guyman loaned me these cool balls. I have a couple of golf balls in here, except I worry that they're a little loud for downstairs. So if you get a chance to do 3 balls, make that one your third, if you don't mind. But the tennis balls I don't think are too loud, and the ping pong balls are pretty good.
Can we go check tennis?
No, it's okay. It's Miss Copel. She's good.
Oh, yeah.
So here's what you're going to do. You're going to put your hand, find maybe the tallest person in your group. You're going to, I think it's nice to start up at 200, but you can choose where to start. Start up high, and then you're going to drop the ball, and somebody else needs to be at eye level so that you can see how high it's getting. You hear me? Now, do you suppose if I do it one time, I'm going to get a real accurate idea? It all happens very fast. And in fact, you probably want to do it a few times and just measure that first bounce only. Okay. Then let's say I settle on, it was at 110. That first bounce got me back up to 110. What I found was when I was in that training, we tried to measure all the bounces at once until it was getting down to the ground, but I couldn't keep track. I couldn't see it fast enough and record it fast enough. So what we're going to do is grab the ball after the first bounce. We're going to see what it bounces up to and then grab it. Try that again, then grab it. Once you get a pretty good feel for where that first bounce went, then start there and do it a second time. Then that'll be your second bounce. Cindy, you don't look like you like this.
Yeah, I'm not getting it.
Okay, so instead of just trying to measure first bounce, second bounce, third bounce, fourth bounce, fifth bounce, sixth bounce, seventh bounce, eighth bounce, I couldn't do it when I was doing this activity. It happened too fast. So instead, what we did was we just did first bounce only a few times. Oops. We did first bounce only a few times, and then started at that place, and then did second bounce separately. And it's not probably perfectly accurate that way, but probably more accurate than you just losing track and things happening too fast. Are you confused right now? Kevin, you gonna be able to explain this to Elizabeth? Okay, so if you would copy down, and you may not get 10 bounces out of this. You just do it until you feel like you can't really tell anymore what's happening.
What are we starting at with 0?
Good question. What are we starting at with 0? Thank you. Your group people will. Oh, you're leaving?
No, I'm doing this one.
Oh, okay. Then your group will fill you in on what I was just talking about. So what do we want to start at? All of these meter sticks are 2 meter sticks tall. If you have somebody that's tall enough, it seems like a good idea to start up top, but you can choose what you want to start with. And maybe you want to do it a couple different ways, and then compare or something like that. Once you've collected all the data that you need to collect, you're going to set it aside, go to your textbook, page 323, and start working through number 1 and 2 and 3. Number 1 is kind of just a practice example. Number 2 asks you to actually use this information. But I think it's going to be better if we collect our information first so that you can all be back at your desks working and thinking about it at that point. Okay? You confused?
How many bounces do you want us to do?
I think you should just do bounces until you have a hard time collecting the data anymore. Because what's going to happen when you're down at 2 inches or 20 centimeters, it's going to be hard to see the next. I mean, you can get down pretty far, but at some point you're going to be at practically 0. Okay? Ready to start? All right. So first thing to do is to copy down this table and then send somebody over to get, I think there's enough for each group to have 2 kinds of balls. Make sure you label what kind of ball you use on your table, okay?
Thank you. That's liquid.
Whatever kind of ball you think makes that you want to do. Do that first. That's totally helpful. But we make a key for this. Probably good practice for just to make equations between two. I want to see everybody in every group get down, get into it, making a contribution. Well, you gotta have somebody to watch for you. It's hard to get your body down fast enough. Who's your person? Oh, Elizabeth, do you just want to join these boys? And I'll just put her with somebody. Is that okay? Then I probably could get those guys in too. Kevin's gonna join your group.
I did. You can't answer.
Really?
Yep. Just proof that there's water.
I was like,
Good. We have more than one person watching it. Are you just the two of you in this room?
yeah.
Did you establish, are you using the top of the ball or the bottom of the ball? You're using the top of the bottom of the ball? Top of the ball. So when you start it, are you doing the top of the ball of the 200? Are you doing the top or the bottom of the ball? Because it's quite a few centimeters difference.
We drop it from the peak.
Alright, so we got 1 full meter.
Zero wouldn't be, haven't bounced yet.
What's the height at time zero? What have we been putting in?
Zero.
Zero sometimes goes with her. Like, remember that bacteria one?
How many just
Oh, it would be air. Hasn't bounced yet.
You could put that in there and then put a little question mark with it. Because that's what you'll do it sure, and then as you go through that.
That's what I'm doing.
Decide if that's right.
So you say it's in this area? Is it 1 or 2?
If you're thinking, if you're building, how high is it?
2 meter sticks.
200 centimeters, okay? So everything you're doing is in centimeters?
No,
200 feet?
no.
Wow.
Doing it. But is it 200 centimeters?
Oh, those are meters, sticks with centimeters.
Wait, why does it say rebound height in feet?
Oh, it does. Oh, you're right. You noticed it says rebound height in feet. Should we change that to centimeters?
Yeah.
Let's do that.
No, just make another thing underneath this.
Nice observation.
Another turn.
Wait for me.
Subtract that from
Let's not do feet.
do this, man. It's like, it was at 65.
Do you usually convert it to the smaller or the
65
larger?
minus 100 is. Centimeters?
Yeah, will you join the girls over here? You would join your group. You guys gotta fill her in on what we're gonna do it. Okay, so you can recreate. Okay.
Do I need a piece of paper? Yes, we do. I brought a paper.
What are you guys filling in for zero?
Don't make that noise, Howard. It's being recorded. Oh, crap.
Zero goes with two. Okay, so you squeezed in 200 once you realized it might be good to have. Okay. How about you guys? What are you putting in as zero?
We have that chart and then we have to have let me catch up.
You know, though, that might be enough. Getting up to 5 or 6 might be enough for you to make a rule about it.
I might break the board.
Guys, did you already do one kind of ball and now you're gonna do another kind of ball?
I would say.
Okay, so we do tennis ball.
Reality that that happens. There's no real physics on it happening.
So bounce
At least 2 types of balls if you find you have time. And you guys have plenty of time so far. If you have time to do a third ball, you're welcome to do that. There's bouncy balls I think in there, and there's golf balls.
What is this?
green squishy ball?
Yeah.
But the tennis balls are green, you have to put small green
They're
squishy
light
balls.
green.
And then we need another, we need like another column.
No, just a different
Do
type.
you record, because I don't have the tennis ball.
Label different kinds of balls.
What did you guys decide to go with? Whatever. Meters.
Okay, so hold on.
So, when you drop something in?
Yeah, we need to come.
Yeah, well, and bowl, when you've done bowls, starting from the top.
We're gonna do each one separately. So what was the height when you got of the bounce?
Tennis ball or the?
Either one.
So 1.023 for the tennis ball and the ping pong ball, so 0.92.
What?
One full meter,
And
then
then
0
0
is
is gravity and extra.
2 centimeters and 3 mils.
This is how my parents.
And if you want to do it, trouble.
I told her I couldn't find it.
Tennis ball again?
If you have time, you sure can do 3 balls, and you guys have plenty of time now.
I had something.
I'm thinking let's do about 5 more minutes of ball dropping, and then we'll make sure that we come and try, because the goal here is gonna be to try to figure out which ball.
Oh, this is tennis ball.
Tennis ball and
And then I'm gonna make another chart for which
tennis ball.
ping pong.
Sounds good?
Ping pong.
Ready?
Are you tired?
I think they're will. They're a little harder. All right, once you've got your data, have a seat, and what your goal is going to be is to come up with an equation to model what we just did.
110. Jazz 110. Why do you have numbers down here? What the heck?
All right, yeah. I don't, let's just go ahead and go with the 2 there. That'll be fine. Create some information, you can get back up and gather some more. Go with what you got. Okay, so now, so now if you put your balls away, and then you're gonna start with number 1 on page 323 here. It's called More Bounces to the Ounce. And then if one of you would read it out loud, just so I know everybody's hearing it for sure. The question that you're trying to get to is what mathematical patterns and some tables, graphs, rules are typical with this kind of activity. When you talk about ball bouncing. So when you make a table, you're going to plot the data that you have.
glad to drop the ball.
And then see if you can make an equation for us.
Let me drop the ball.
Okay? Ready, go. Alright, so you guys, I just want you to stick with 2 balls since you're down here. Doing the textbook stuff.
That is, so this is it.
So you close?
You don't have to do that.
One more.
Are you guys ready? 12. You got 3? Good, and you about done? Okay, so you put the balls away, and then go to page 323. That activity will kind of guide you through. The big goal here is going to be, you're going to pick one of those data sets to begin with. Plot the data, and then try to come up with an equation for it. Once you kind of determine how you definitely got lower every time, right?
Yeah.
But was it by a consistent amount, or how could you? But you have your data set. Right, and that's a good point, we're gonna talk about that. Real life data, is it gonna be perfectly predictable every time? There's a lot of it, but do you think we could get a general model that's at least decent?
That one I was like,
So we usually slide over with
let's try that again.
Are you just kind of playing around with it, thinking about what it might be? That's what we do on number 2 anyway. At some point, when you get to something that's so wacky, it starts with page 324. You want to this stuff, pollution, and then this is a nice example of some of this data. And you come up with an equation, just to kind of get you on the right path of what this looks like. And then number 2, you're ready to do your own. If you feel the urge to play around with it,
Tyra, you don't need three columns.
because if you do that, then you'll have number 2 done with creativity. Okay, you guys got your data collected? Elizabeth, do you want to go over with those girls? Can you work?
Yeah, I was just playing.
Are you done? You got them collected? All right, have a seat and grab your book. We're going to start on page.
She's got a,
Go grab your stuff if you need. Usually we'll over it.
yeah,
Because I left Kevin in, so now you'll be all by yourself in your data.
yeah.
So what you, just so you know, what you guys are working on is really number 2. So when you kind of get to a standstill, you may find that it's tougher to find that rule than you think. Maybe it's not, maybe you don't have any trouble. But once you are ready, would you start on page, yep, on the bottom of that page that we were just at. There's a little introduction paragraph right here. Yeah, will you read that, maybe read that to your group while they're plotting. All right, you guys know what to do? Okay, so you got this data now. Awesome. Okay, so we're just gonna choose one of those. Just choose one of those balls. And what you're going to do is plot. Did you find that the decrease? And we want to know, is it in a predictable way? How do we make Okay, so you chose every column, and then how are you going to find the equation? Wait a second. It started at 200. You dropped it and it went only up to 16, and you dropped it from 16 and went only to 20.
We haven't dropped it yet, so it'll be 0.
Okay.
So what?
I thought you meant we'll take off that, and then it goes back up to 200.
That just makes sense. They haven't dropped it.
What do you got?
And then to 2.
Okay.
So what's the plan? You're going to come up with an equation for this.
Are you guys going by a certain number?
I'm going by chunks.
How are we doing it back here? We did that here. What here? Go back to this. We already did this. When we were doing cafeteria, we're good to use. If you want to come up with an equation for this, what was the, what are you Yes, now next is a great way to start. Now next, so what are you on the Will you start that? So you don't lose this idea. This is great. Next equals. What do you think? It's decreasing exponentially. Nice. So then, maybe you want to grab a calculator? What's the deal with exponentially decreasing? What is our, is it going to be now plus something, now minus something, times, divided?
Let's fix up your own data. Are we doing all of one? Let's make it the new one.
When we were talking about exponential, that being good. What was the deal? Which one was it?
Wait, did we get, did you pick up 3?
9, 27. What was the 9?
See, well,
Times
two,
times by
and
3.
then one.
So
Anything less than 5 is
so maybe you need to figure out what you're dividing by. Or
It's
if you want to set it up exactly the
0.972.
same, you might be able to
So it
times
stays the
7
same.
but
No,
maybe
it
something
stays the
less
same.
than 1.
It's the first three.
Because if you multiply by something less than 1, you would expect that one to.
It's like if you have two, it's like if you have two.
How about this? If you're struggling at all, why don't you try to just do a now next rule? So for example, if I started at 200 and then it went up to 110, I might say to myself, okay, 200 times what gives me, because wouldn't it be nice if we could make it fit the rule? I mean, I'm hearing from different places, exponential, it's something about exponential, and in fact, we just did some exponential stuff, so that's a good clue. So if it was going to fit our exponential rule, what would we have to multiply by? Is that what you're kind of, get a calculator. Don't wait for your neighbor to do it. Get a calculator if you don't have one and try some stuff. Okay. I will not give you any heat at all if I can see a list of things you've tried. Even if everything you've tried is wrong, at least I'll know you're actively trying stuff. So let me see what you're thinking and what you're trying. Write it down. If it's wrong, lightly cross it out. That's okay. Yes, ma'am.
Yeah, now, next. So you put, for like now.
Come on, here's one.
Start by? Okay, one. I don't like it.
Now next just means pick a spot on that table.
Okay.
Point your finger to the Y value on the spot on that table.
Wait, how many do you think that would be the Y value?
Yeah, pick one. Pick one
Because
line.
as it
64.
decreases,
So you say to yourself,
generally it's by half.
I did.
So it's going to look like.
So
Okay, wait, now put a number in for
The
X.
now, you just picked the 64. What do I do to get to the next value? That's all a now next is. And it's a nice little baby step to play.
So I can do now equals 64 and then now equals 64 times X.
What actual number? Grab your calculator. What actual number are you multiplying by to get?
no, 200 over 2 with the next one and the next one.
No, you can't.
Yeah.
Okay, then go get a calculator. Once you hang on, Elizabeth, once you get that, you're going to take 64 times something. Try
No,
some stuff.
2 with the
It's okay to
X
just
or next one.
64 times what is going to give you
30.
30.
Okay.
Like, if you
Be a negative.
Go take that.
Because it's gonna, it can't be.
Okay, so 64 times 1/3, it's the same thing where we were talking about multiplying by a fraction. Okay, so you might say 64 times 1/3. What is it?
So 64.
2.1.
So next equals 60.
30. 64 minus 30 is 34.
Yeah, then I
Okay.
did 64 divided.
I'm gonna zip my mouth and let you play around with it a little bit.
So I would have one more question. So it'd be, when you do next, it'd be like next equals now?
The word now. So that when I come up to your paper, I can pick whichever Y value I want, and you have a predictable way for me to get to the next one.
Next equals now.
But remember that this is real life data, so it's probably not going to be perfect every time. If I pick a different place on your table, I may end up with roughly the next answer.
Oh, okay.
Okay, now
You know how to do that, that's too helpful. Okay.
This is so bad.
Not so tight, but you just ask her what she thinks too. Are you doing okay? How's it going?
This is like 64.
Ah, so instead of multiplying, you're dividing.
Times 1. Starting at 64. Oh, that's
What was it supposed to be? For 16. Try it with some others. You might be on the right track.
Oh,
But your data, if you didn't get right down there, if you just, if it wasn't perfect measurement, we talked about how you measure the top.
Yeah, whatever.
I won't eat it the entire day until we go to keto, and that's okay. So, but try it with the next one. What if you had gotten 40? 40, try your rule again and see if you get him next. Okay. Nice. Some of you are using division, some of you are using multiplication, and both of those are good ways to go. I think you figured out adding or subtracting strictly isn't too effective. That's why we know it's an exponential. So you guys are doing number one first, to get yourself warmed up and ready to do the next, to do the data next. How about you guys? Which one are you working on? Mackenzie's not in here. Are you guys talking and communicating? No?
Or 1.5. Always half.
There. Ask Mackenzie what he thinks.
Like sometimes those are.
What are you guys working on? The green bump. I see a plot. It's
What you're
beautiful.
saying, you're like super quiet.
Your plot is beautiful as well. What kind of curve is that? Straight line? Exponential way you're gonna do it.
Are you quiet?
Septic's going downhill and the other exponentials are going uphill. Is that a nice. Where'd you hear that word? In A. Good. And also, and also it's the name of the section that I'll take it. So exponential decay means the amount's getting smaller every time, but it's in a predictable way.
60 stereotypes.
You don't think it's predictable here? Okay, so have you played around with maybe what a row could
Trying to.
maybe you write down some of your ideas, even if they're wrong, just so that when I come by after like this, I'll be like, oh, you're bouncing stuff. Next, now, which one are you choosing? The green one? Just with only a three. So what I'm asking is 200 multiplied or divided by something gives you 40. Right? Now next, that's from science class. They're doing their time. It's experiment day. Okay, so how are you going to get from 200 to 40? If you find yourself frustrated, you guys go to number one. Because number one, they're giving you some data.
What about next?
Somebody.
Try it.
Wait, what is
Where's your calculator? Get it out. Be active.
5 is 200.
Roughly is working.
40.
Is it?
Sorry.
Yay! So if we're next to that was now times 0.33 times. So you're talking. What is it? The green bump. Let's put a star by that. I know which one you're doing. Okay. So you're telling me if I take 200 and I times by 0.33, I'll get 60-ish? Exactly. Okay, and then if I take 60 and I multiply by 0.33, I'll get 20 times 133, 18-ish.
We could do this for the
Nice. You guys must have measured accurately then. That's working nicely. Okay, so then now you got your numbers.
Doing my
How can you
homework.
make that into an exponential? Do we know the starting? Yeah, y equals a great. And then, so from here, so we're at y equals, and then set it up like you guys did with the bacteria ones. I'm gonna set it up growing, and you put 0.33 in there. The amount shrinks.
Okay.
Are we on number 2 yet?
No, I don't.
Can you start?
Oh, dividing by. Okay. Can we try to mind this the same thing that we did?
I got one.
Yeah. And then
How to show it?
it's the same.
Well, you've got your table on top, right? Okay, can we start from now?
If we do this toss it, it's like that. We did. If we do
Next equals now times 2/3.
it comes out at 1600. You
Oh,
can't
did you actually-
times by
where is the
positive,
table?
you times by negative for it to go down.
No, for the,
And it does the same thing as dividing by.
yeah, wait a second. How do you
Dividing
do
by
2/3 of
our boxes are here.
Now, let's do, okay, but then you decided to do number 1 first for a good one.
This is the same thing except
But it starts at 27, and I see that you're saying 2/3
And then that was
is 17.8.
Keep your mind out. 2.56 times 2.6.
Sorry, I didn't want to make sure you said that. I didn't get what you were saying because you're really quiet.
Do you think 0.66 would be, you need more sixes than that? Reading, I thought. No, you do not. Who rounds?
I played that
I
game.
don't. I have been around, especially with that. So push a bunch of sixes. You say repeat and repeat.
It's like,
Okay, let's think of this in a different way. Okay, time out.
Anyways.
Let's not use our calculators for a second. When you were a kid and you learned how to do
Oh.
you learned how to do two
Okay, I'm
thirds.
like,
If I have 27 cookies,
they go.
how do I do two
God,
thirds?
I figured out what you
Oh, I'm sending you back to Ellen.
Okay.
How do you do it? You know how to do 2/3 of something.
27 over 1 times 2/3.
Do that. Do that. Do that. Do that. 27 times 2/3.
Okay, whatever.
But then how did you actually divide, or would you actually write the cross?
Times across.
All right.
Nope. Nope. Cross multiplying doesn't work. It's a big lie.
Yeah, that's what they told me.
No, they did not.
Actually, they did.
No, if
Join
it's
the
equals,
alien
if it's 27 over 1 equals 2/3.
To get to 99.
Then you can actually multiply each side by the denominator, and that's what cross multiplication is. But that's why I don't like it, because you can't do it when.
Wouldn't it be-
So when you multiply fractions, it's just straight up, when you multiply fractions.
You told me to stop drawing. Now you're messing with my calculator.
Times 2. Is 54. So 54 divided by 3.
Just give me a headache.
I did this one.
The numbers are like the keyboard.
Your calculator must be
But I'm
faulty.
No, we can't run negative because we didn't do it.
Oh,
I pressed time.
Okay. So 54 divided by 3 is 18. And do you want to know how I do that one really super quick? I say to myself, if I have 27 or something,
If you're timing it, it would be negative. If you're
and I
dividing
put it into 3 groups,
positive.
how many would
Then
be in
it's
each
the
group?
same thing.
Not much.
So in other words, what's
No, it
27
is.
divided
Okay,
by 3?
so do 200
I'll just
over.
replying to this.
Oh.
So 27 divided by 3 is 9. So now I got a group of 999.
Negative x.
And if I take 2 of those groups,
200 divided by 2
2
is the x.
9 and another
It's
9.
the same. Like I put 3 in both the equals.
They did.
And they both
So, hey, now you got a fraction listed in there too. Okay, so back up to this one. 18. So the idea is that if you take this number, and you were up there trying to multiply by 2/3, you get 18. Multiply by 2/3. So your table needs a little adjustment.
Negative.
It's actually not located around the back.
a negative.
If you want to type in a bunch of sixes, put 6, 6, 6, 6, 6, 6, 6.
You just write it down and put it in a
Without
number and then
after-
show me.
You just have to make it more accurate. Because you were showing
Just write down what you think.
27 times 6.
Put the x.
If I do this, your calculator will answer correctly. So if you choose to do the decimal thing, you gotta remember that it is repeating and actually type it right.
But then it's different.
Okay, so back to your example.
I mean, negative.
The idea would be that you need to find out how to get from
If you do negative, then I don't think we should do the decimal.
Is that okay? So you take your starting amount, what do I have to multiply by? Because that's what we did here. We multiply by a number to get
Well, I guess
times what gives you 1.2.
Yeah, we can do that. But it's not gonna
So
be
you're gonna have to probably play around with it experimentally.
25.
Or maybe you'll find a way to divide and find that number easily.
200 times.
But that's where you're gonna start.
The
So
negative.
we
And
can
if
now,
you do
let's
negative.
do number 2, what's number 1?
You still get 1600. You put 3. And you put negative 2 to the negative x. It's just down to negative 2.5. We need a positive sign. Looking at the numbers. At least get a probable and tape measure or manuscript.
Tell me, can you kind of recap what you were just talking about? That was a good talking, good discussion. Oh, no, are you into this discussion?
Yeah, I'm just getting this done. I'm trying to figure some stuff out.
I know, but that doesn't help your group. Share with them. Talk out loud about
I'm understanding.
Do you have tables? So can I refresh your memory about the last one with the bacteria? Like, there was bacteria and it was at 64 times 0, right? And then we started by doing a now-next rule. It was like bacteria, there's 64, and then there's 128, and then there's 256 or whatever it was, 1, 2.
Those are more like specific, like it goes up the same.
Yes.
These are, like what we came up with was 200 times 2 to the negative
200 times 2 to the negative. Oh, we did. Does it work?
It's close, I was trying to see if they still has 0.6.
So
But like it's like 5 away each
2
time.
feet is different.
Or like it keeps getting a little away. Like it's doing the same process, but it's not doing the number seconds.
okay, I gotta tell you something. Negative x. So what are we talking about negative x? So I like going back into it. Remember that? That looks right. But you know what's calculator? Can you show me your calculator? When he put in 2 to the negative x, it made it into 1/2 to the x. Are you guys trying to put any decimals in for me?
Yeah, I did 1.5. Like I was trying to go down and see if the number would be more, but it was way off. I didn't try 2.5. I tried 1.5. I went
So if you
5 down. So we were originally at 2 and I went 5 down.
I think you're gonna find that you were on the right track with that negative exponent. What that does is put a fraction in the piece. And his calculator like actually showed that you guys had a good idea. And you it's easier to read. But I think they must have a huge number and they're bigger than 1.
Measured.
You're multiplying by a number bigger than 1. Your balances are gonna get bigger and bigger.
Do we want to divide?
But it, well, dividing is the same as putting in a number less than 1.
So,
Like in other words, you talk about.
Yeah, we have like the 2 times 2 the negative x is the same as 200 divided by 2. It's the same.
So, 200 dividing by 2 is the same thing as multiplying by 1/2. So I'm wondering if you want to try and the problem with just doing the 2 is that you're limiting your base. Your base is only 1. Like a multiplied number here. You're changing other stuff, but if you put a 2 in here, if you put 2 to the negative x in here, this is half.
you want to take my spot? I'm trying to get
So what if you tried it with different
Yeah.
decimals? So you, what did you start with? What's your start?
It's a good class, but it's
Are you
usually.
settled on 200 being on front? Okay. And then what if we put a fraction in here? Or a decimal or something? That's something, a number that is less than something. Go try that. And then to the x power, and that's what that number is.
Yeah,
Okay, was it
we
like
did
2
1.5.
high? Experiment around with that.
we did 1.5.
We tried again and just see. Try what 0.5 does, and then maybe need to, if it's too low, maybe need to raise it up or go out from there.
Maybe less.
No,
than
not.
They have their first one done.
Yay!
Let's do.
Excellent. 0.56 to the x power?
Yeah.
Wait, are you agreeing?
Y equals 1/3.
Awesome. So you're gonna do number 1 and then come back and like number 3 is do it with another ball. So if you've only done, and which ball is this? Is it one label which ball you're working with here? TB. Maybe this one. Oh, okay. Will you write that on the side? How do you know, Tanner?
You said it's 2 points.
Because it's the same thing. It's like,
Or those are 2 questions.
like, you know how like it's parallel,
Can I try it out?
parallel, like this could be like this,
so tell
but I
me.
think 200
We started with 200. And then it's 1/3. So I'm gonna, whenever I do a fraction on my calculator, I'm gonna put it in parentheses. To the what power?
To the x power.
So 200 became 66.
Yes.
So 6, and really it was 64, but that's pretty, that's not too bad.
Yeah.
Okay. So then what
It's
if I
supposed
do
to be
it
right
again?
on.
It will, no, it will not be right on, because it's real life data. How about 22 for the next one? And yours was really 30, not bad. What about
Just did.
to the third? 7-ish?
Oh.
okay, so then we have
I think this is pretty good.
0.5,
0.02 seems very small, but the ping pong ball is so great, the little super cut. So the
Yeah, the ping pong would only jump so far. It would be like
a lot deader than.
like you drop it farther and then it'd come like it is like this much.
So 0.02 to the first. So your very first one all from 200 all the way down to just 4? Oh, 99 and 4 is really nice. Do you think maybe that second one needs a little more work?
Yeah, I think the second one is way.
I'm thinking 0.2 might be a little bit too.
So let's try 2.0. That's what I heard first. Let's just try it.
Oh, do times. Do times. Oh, no, you're doing it. You're not listening. You're just doing it.
Let's do.
What if you
Yeah.
try?
That's what I thought. That's what I
And don't
thought.
erase, will you just lightly cross out that?
Everything just
And write this, try this, and see if it works. If it doesn't work.
Yeah, well, Jasmine
Hang on,
first said
I'm not convinced of 2.02 yet. You better keep trying. Like, test it out. So if I was to walk up, I would test it out by doing 200 times.
200 times 2.
Ah.
Oh, no.
Oh, no.
Sorry.
All right.
No. Oh, look at the graph it made.
Wait, that can't.
Second, I gotta press second graph to get the scale. Oh, no, it's
Still here.
So I saw Jasmine had a great idea though. She was trying to figure out, like, remember in middle school they would be like this, like 200 times something equals 99. And Jasmine is remembering that there was dividing involved. So she did 200 divided by 99. But if you're trying to find out what this is,
It's like 200 divided by 9
let's call it,
times.
what if we call it x? Would that help? 200 times x. How would you get x alone? You guys want to work together on that? What would you do to each side of that equation to get x?
You'd have to split it.
And then do the,
Like the solving on both sides of the balancing.
yeah, do it. So I'm saying, she on her calculator has 200 divided by 99. What's the step here to get x alone? How are we doing? Then check your understanding on this is your homework. Okay?
So what's the page?
It's on page 325. If you're ready to move on to homework, that's fine.
We got it.
Got one? Okay, I'll come check. And the way I check it is I ask you to tell me your starting number, and then I actually put in your rule, put a 1 for x,